Good morning, ladies and gentlemen. Day 2 of lesson 11.2, rational functions, translating. We're going to be shifting them today. Today we're actually going to be graphing them. So big important part is the first thing you're going to want to find before you graph these things is vertical and horizontal asymptotes. When we're done with this lesson quick, you're going to be able to finish up your 11.2 try on your own, and then make sure by Monday night, you virtual people, you send either myself or Mr. Myers a picture, whoever is your grading teacher, a PDF of your assignments by midnight, Monday, April 12th, okay? And we're going to come along here. We got a rational shift in behavior, our warm-up. We're going to be graphing 2 of these. Well, actually 3 of these. I'll go through the first one with you, and it's really obvious here. Where's my vertical asymptote? My vertical asymptote is here. It's going to be at x equals 0. And what I'm going to do is I'm going to graph that vertical asymptote. And the next thing I think of is I like to think about where is my horizontal asymptote, and I find that out by mentally saying 1 divided by this bottom is getting bigger and bigger and bigger, so that bottom's getting bigger and bigger and bigger, which means this is getting smaller and smaller and smaller, and it's slowly getting to 0. So I have a horizontal asymptote at y equals 0. So I would graph that little bugger, and then mentally, this is all what I did right there. That is all mental math to find my horizontal asymptote right now. And that logic is going to change here in a little bit, but that's how we're going to do these baby ones. And then from there, I am just going to find out where are my 2 branches. Remember, my branches were either here, or they were here and here. One of those 2 spots. And they can, move around, but my branches are either going to be right next to each other or right across from each other, and it's as simple as that. So in my mind, I'm going to picture an XY chart. I'm going to say, hey, if I plug in a 1, I get a 1 out, so I'm at 1, 1. Well, there's a particular behavior as I go way out to the left. I'm going to get snug as a bug in a rug to my horizontal asymptote, and there's an asymptotic behavior as I go closer and closer and closer to a vertical asymptote. I either go straight up or I go straight down, and in this case, I know I'm going straight up because there's no value for x I can plug in here and ever have this thing output 0. It's going to get really close to 0, but it's never going to hit it, so that's how I know it goes up, because if it went down, I would cross that asymptote, and we're not going to do that for this one. Next thing I'm going to do is I'm going to plug in a -1. That's going to give me a -1 out. So here I know my branch is going to be over here as well. So why don't you give these next 2 a try here, and I will be back in just a second. So I just did the second one, so hopefully your second graph is right. I'm going to do the third one with you because this one kind of changes up a little bit. So the first thing I'm going to do is I'm going to say my vertical asymptote is going to be at x equals 5. So I'm going to come out here and say 1, 2, 3, 4, 5. And I'm going to draw my vertical asymptote in there at x equals 5. Now from here, I'm going to say, where the heck is my horizontal asymptote? And I'm going to mentally think of a very big number in there. So if I take -1 divided by really big, but it's still negative because, it's going to be positive. It doesn't really matter if it's positive or negative, because a constant, a number that's not changing, divided by a number that's getting bigger and bigger and bigger, is getting smaller and smaller and smaller, and it's approaching 0. So my horizontal asymptote is going to be at y equals 0, so I'm going to draw that in there. And then all I have to do is mentally, I am picking a point on the right side of my vertical asymptote because I need to see where is my branch. So if I put 1, 2, 3, 4, 5, this would be 6. If I put a 6 in here, I'm going to get -1 over 1, and I'm going to get 6 -1. So I'm going to be, my branch is going to be down here this time. Because remember, that negative is going to reflect the x-axis. Also, if I put a 4 in there, what's going to happen is I'm going to come back and I'm putting a 4 in here, so that's going to give me -1 over -1. That's going to give me 1. So if I put a 4 in there, I'm going to get a +1, which means my branch is on this side. And there I go. I got them graphed. It's all mental. Okay, most people say, I did it in my head. Well, great. Now that's how we actually want you to do some of these. But it's important to be able to write down as equations what your asymptotes are, like I did right there. Next thing we're going to do right here is we're going to come across here, and you can read all this shifty behavior take 2 on top of this, but what we're going to do is, without using a calculator, we're going to sketch each function and show asymptotes with a dashed line. I typically show my asymptotes with red lines, and I will continue to do that here. So what I'm going to do is I'm going to walk you through one example that I got here. And I'm going to cross that one off here because we know all of my functions are going to look just like this for the most part. They're just going to be moved to a new portion in the coordinate plane. And this is what that one looks like because I have a vertical asymptote, VA, at x equals 0, and I have a horizontal asymptote at y equals 0. So that's why I did those. Like I said, I do them in red, and they should be dashed as they can. Okay, so what I'm going to do is I'm thinking here, I have a process I go through. I think, where's my vertical asymptote? Well, my vertical asymptote is going to be when x equals 2. So then I'm going to come over here, and I'm going to say 1, 2. I'm going to graph that asymptote as a vertical dashed line. And the next thing I want to know is that where the heck is my horizontal asymptote? Well, my horizontal asymptote, think about it, as the denominator gets big, this is going to approach 0. So I'm going to be at y equals 0. So here is going to be my horizontal asymptote. And then from there, to figure out what's going on, I'm going to get rid of those because that's how I found them. I'm really mentally, these asymptotes are mental math. I just wrote them down for you. And then mentally, I'm going to make an XY chart because I need to find out where are my branches. Are they here and here? Are they here and here? Are they side by side? Or are they side by side? Where are they? They're never going to be on top of each other like that because then they wouldn't be functions. So I'm just going to mentally make a table of values. But how I'm going to do this is I'm going to pick a point on each side of my asymptote. So I'm going to say 3. If I put 3 in here, well, that's going to output 1. So that's going to give me over 3 up 1. That's going to put my branch here. And if I put a 2, oh, I can't put a 2 in there, you fathead. That's my That's my vertical asymptote. So I got to get rid of that 2. I'm plugging in on the other side of that, so I'm plugging in a 1. And that's going to give me 1 over negative 1, which is negative 1. So I'm going to go 1, negative 1. And here is my branch. That's all we're going to ask you for. So why don't you go ahead and do these next 4 problems and see if you can get them. And notice the next 3, they are squared. So give it a shot, and I'll be back with the answers. So as you can see there on that last one, okay, I can see my vertical asymptote is at x equals negative 3, so I drew it. I have a horizontal asymptote at 0. And then all I did was I'm just doing this for the virtual people, I mentally make that chart in my head, and I plug in a value on the right side and on the left side of my vertical asymptote to figure out which side my branch is on. And when I put a negative 2 in there, I get negative 1 over 1. I get negative 1, so that tells me my branch is down there in quadrant, or kind of not quadrant 4, but down underneath the x-axis, and the other one's on top. Notice both of these, everything is the same. Both of those look identical to this. They are just shifted. One shifted right. The first one is just shifted right 2 units. The left one is shifted left 3 units, and it's reflected. So it's shifted left 3 units, and it's reflected because of that stuff right there. Okay. The next one we're going to do here is we had the y equals 1 over x squared. Well, remember, this is only going to output positive numbers, so that's why I'm above the x-axis there. So all of these other 2 examples are going to look exactly like that. They're just going to be shifted or reflected, one of the 2. Okay? And we can be right back here in a second for those. Okay, so as I'm looking at this this next example, I can look here and I can see my horizontal asymptote is shifted over. It's at x equals 2. And everything else above is the same. So this next graph is going to look exactly like that one, except it's going to be shifted to the right 2 units. Check it out. Okay, there it is. It's the exact same graph, shifted right 2 units. This last one, I can see my asymptote's at negative 3. So this one's going to be shifted to the left 3 units, and it's going to be reflected. Okay, so there it is. It's shifted to the left 3 units, and it's reflected. And I forgot my arrow right there. So that's how we're going to graph. Find your horizontal asymptote, your vertical asymptote, and then just pick a point on each side of your asymptote to find out what section your branch is in, and we will be done. So shifty behavior, take 2. Okay, so what we're going to do here is without graphing, let's determine the number of vertical asymptotes for each function. Well, remember, vertical asymptotes are going to happen technically when my denominator equals 0. So how we're going to do that is we're going to take that whole expression in the denominator, and we're going to set it equal to 0, and we're going to solve for x, and we're going to find out x squared equals -2, and when I square root, I find out x equals an imaginary number, okay? And so because it's imaginary, this is going to have none. There's none in that one, okay? Notice, they're imaginary numbers I can't graph. So the next one, again, I don't care about the top to find my vertical asymptotes. I'm just taking the expression in the denominator, setting it equal to 0, and I'm going to get to 4. But now remember, when I square root, when you're solving an equation, we get a positive and a -2. So this is going to have 2 vertical asymptotes. It's going to have one at x equals 2, and it's going to have one at x equals -2. Okay? And that's what we're going to do. And we're all really good at our algebra with solving quadratics. So this next example, we have to take x squared plus 4x plus 4, and we have to set that equal to 0. And remember, when we solved quadratics, factoring was the best way. And I can see this is going to factor with an x plus 2 and an x plus 2. So I can see I have a vertical asymptote at x equals -2 and a vertical asymptote at x equals -2. And because they are the same one, this will have 1 vertical asymptote. Okay? So that's what you're going to be doing. So what I would like you to do after seeing those examples, we're going to have no, none, 2, we might have 1. It's actually possible to have more than 1. It all depends on what degree the denominator is. So if I have an x to the 3rd down in the denominator, I could have as many as 3 vertical asymptotes. If it's an x to the 4th, I could have as many as 4 vertical asymptotes using the fundamental theorem of algebra that we learned earlier this year. So what I'm going to do here is I'm going to just do A with you, then I'm going to shut her down, and you're going to try these problems, and I'm going to come back with the answers. So what you need to do, analyze each rational function, use algebra to determine the vertical asymptotes. What you do, again, you take the expression in the denominator, 7x minus 35, you say, when are you 0? And you solve and find out when that denominator equals 0. And whenever that denominator equals 0, we have a vertical asymptote as of right now. Well, not necessarily, it's an undefined value, but it may or it may not be a vertical asymptote, okay? And we're going to figure out when they are and when they are not. X equals 5 will be. So why don't you try the rest of these, 2, 4, 6, 7 of them, and I will be back. All right, so I'm back here on part B, and we are looking for vertical asymptotes on these rational functions. And remember, all a rational function is it's a fraction, and it has to have a variable in the denominator. If it doesn't have the variable in the denominator, if it's like this, that is not a rational function. That is actually a linear function, because I can peel that x off the top. It has to have a variable in the denominator to be a rational function, okay? And what I can see here in part B is I can see both of those, or I can see my denominator is already factored, so all I do is I set each factor equal to 0, and I solve it, and whatever it solves to is a vertical asymptote. See, that one's going to have 3. That one would be fun to graph. And then we're moving on to C. Well, what's going to happen is I got to take that denominator, set it equal to 0, and I need to factor it. And just because something doesn't factor doesn't mean it's not going to have a vertical asymptote. It just means they're not as nice. But notice this one did factor, and I have one at x equals 5 and -2. And over there in letter D, I'm taking 2x squared plus 9x plus 4 equals 0, and I'm factoring that. And that's going to factor in 2x plus 1 times x minus 4. Therefore, I'm going to have a vertical asymptote when x equals -1/2 and when x equals -4. And we're moving right along here. And this next one's kind of fun. That x squared minus 16. So I take that whole thing, set it equal to 0. Remember, we need to factor, because if you don't factor, I already know people are going to lose some of these asymptotes. This could have as many as 4, but x squared, or x to the 4th minus 16 factors to x squared plus 4, x squared minus 4, and this x squared minus 4 factors further because it's a difference of squares, so I get x squared plus 4, that one doesn't factor because it's a sum, and that goes to x plus 2 and x minus 2. So what I do is I take each factor, I set it equal to 0, and I know x squared plus 4 is going to equal 0, so x squared is actually going to equal negative 4. That's going to be imaginary, so there are no vertical asymptotes from that factor, but there's a vertical asymptote of negative 2 from that one, and a vertical asymptote of 2 from that one. And when I come over here in f, I take x squared plus 2, set it equal to 0, x squared equals negative 2. When I square root that, I see it's going to be imaginary. Therefore, I have no vertical asymptotes because I can't graph imaginary things in the real coordinate plane. And the last two we got here, they're kind of interesting little critters here now. So I have n of x and p of x. And n of x, well, what we're doing is we're looking, and it sure appears, it looks like there's going to be a vertical asymptote at x equals 2, and it looks like p of x is going to have one at negative 2 and x equals 5. But guess what? It's not. That first one, g of x, is not going to have any vertical asymptotes. And this p of x over here, that is only going to have one at x equals 5. Well, that's kind of interesting. But if you look back at the original functions, it kind of makes sense. And what I'm going to do is I'm going to hit pause here really quick, and I'm going to graph these two functions in my calculator, which is what you should do for number 3 in Desmos to make sense out of this. Why does the first one not have an asymptote and the other one does? Because it sure looks like it does, but the graph is definitely going to show it does not have one. So I'll be right back. Okay, so when I come back here to g, my n of x function, 2x minus 4 over x minus 2, when I graph that in Desmos, it'll look weird. It's a linear function. But also, if I use trace, see, we were totally expecting, I'm going to take red, we were expecting a vertical asymptote to be right here, right? And if I trace my graph, if I say menu trace, and I want to trace my graph, and I want to go to when x is 2, see right now, I'm down here at 0, 2, that's where that x is, and if I want to see what's happening at 2, enter, notice at this point, right here, okay, that's going to be 2 comma undefined. And it's showing even a dashed line. It's showing a vertical asymptote when 1 doesn't even exist. In my calculator, that just means, hey, it's not here. There's something going on there, but it certainly is not a vertical asymptote. And when I come over here and I look at my other graph, I expected a vertical asymptote, not only just over here at 5, right here, I also expected one over here at negative 2, didn't we? But I don't have one at negative 2. There is one over there at 5. I can see that in the graph. But what in the heck is going on over here? If I came over and I traced my graph, and I traced my graph over here at negative 2, and I hit enter, notice they're saying, hey, dude, it's undefined when x is negative 2. It's undefined. And it's kind of showing me that black dashed line. It's kind of showing me, well, you know, it ain't working here. I made my green line in the wrong spot. They said, hey, we don't have a vertical asymptote here, but something's going on in that function to where we can't evaluate it. And, you know, it's an area. It's a domain restriction, but it's not a vertical asymptote. All right? Well, what does that mean? What does that tell us? Well, once we look closer at that, okay, we used our graphing calculator to check our answers to 2, and we graphed and we analyzed the graph, so we used a trace feature to say, hey, it's still undefined. Comment on any discrepancies in your answers. Well, basically, what I'm finding here is when I take that original function here, I'll leave that there, and I'll just bring these both down. So when I took n of x, I'm looking at the top, and I'm kind of thinking, oh, okay, well, I have a greatest common factor up here that I can pull a factor of 2 out. So that reduces to 2 times x minus 2 over x minus 2. And check it out, I can see that thing that I thought was a vertical asymptote actually reduced out. And on my p of x over there, x plus 2 over x plus 2 minus 5, right out of the blocks, I see I can reduce, and this actually equals 1 over x minus 5. And check it out, we did have a vertical asymptote at x equals 5. At x equals 5, there was a vertical asymptote, but this one wasn't an asymptote. And over here, when I reduce out, this one just equals 2, doesn't it? Well, that makes sense when I look at my graph, because check it out, my graph is just constant at 2. You can see that. And I'm just going to get rid of that dot on there. It's y equals 2, but it's not defined at 2. All right, so that's what it is. So what does that? Can't get that on. What does that mean? Well, what that actually means, this is a good thing to get in your notes that I'm about to reveal. When a factor that looks like a vertical asymptote, like these two examples right here, when a factor looks like a vertical asymptote, but it reduces out of the entire equation, this is actually an invisible hole in the graph, okay? It's not a vertical asymptote, it's going to be a little hole. We will talk more about those coming up in the future, but it's really important knowing that now. And the last things we're going to do here is determine two different rational functions with the characteristics given. Well, I think we can handle this because all they're doing is they're telling me I have vertical asymptotes. I got 1, I got 2, I got 3 vertical asymptotes. So it's going to be a rational function, which just means my f of x function. That just means it's going to be a fraction. And if I have a vertical asymptote at x equals 3, that means I have a factor of x minus 3 in the denominator. If I have a vertical asymptote at x equals -1, that means I have a factor of x plus 1 that gives me -1 up there. And if x equals 0, well, that's just times x, okay? And look, there's vertical asymptotes, and if I put a 1 in the top, that's fine. And if I rewrote a whole brand new function, g of x, that still has those exact same vertical asymptotes underneath, but it's a completely different function, well, maybe I just put a different number in the top, and it's going to be a different function, okay? And then part B, vertical asymptotes, I got 1 here, I got 1 here. This one gets a little tricky, though, okay? Remember what this x equals 1/2 looks like. So I'm going to have an f of x here, and it's going to be a fraction because it's a rational function. I'm going to deal with the easy one first. Well, that factor is going to come from x plus 2. But how the heck do I get it to be a half, all right? So I'm going to say x equals 1/2. And if I work this backwards, times 2 times 2, I'm going to get 2x equals 1. So when 2x minus 1 equals 0, hey, there's my factor. That's how I got the 1/2. And it's 2x minus 1. And if I need two different ones, maybe I want to put a 1 on the top of that. And maybe my other function that I want to use that has a vertical asymptote at -2 and at 1/2. Maybe I want to put a 15 on top of that one, and they're different. As long as they got different numbers on the top, they're going to be different functions. And that rounds us out for the day here, guys. All you got to do is finish up your 11.2 try on your own, and make sure you turn it in by midnight with 11.1 midnight Monday night. Have a great weekend. We will talk to you soon. Bye-bye.